A manager wishes to determine the relationship between the number of years her sales representative have been employed by the firm and their amount of sales in thousands of dollars per month. Find the equation of regression line. Okay. What I like, you don't worry about those. Just let's answer the question. So I'm going to remove, not just those questions here because I put them already there. I forgot to delete them. First question. Find the correlation coefficient R and interpret its meaning round to 2 decimal places. So, well, in order, guys, to do this, you have to enter the data into L1 and L2. And let me do this together. So I'm going to stop share and no, probably I'm going to keep it there. Okay, so let's go to stat, edit, and input the data in L1 and L2. So I got 2, 3, 10, 7, 8, 15, 3, 1, 11, go to L1, and then go to L2, 31,000, 33,000, it's in thousands, he says, 78,000, 62, 65, 61, 48, 55, then 120. Okay. So the correlation coefficient, guys, if I do that, I go to stat, calc number 4. I get R equals 0.63. Is that what you guys got?
I got 620.
620 or 6320?
No, I just got R equals 0.62.
Let me see. Let me see if I made a mistake. 2, 3, 10, 7, 8, 15, 3, 1, 11. And let me check double.
It was actually my mistake. I see that I put 4 instead of 7.
Oh, okay. Okay. So let's do it. Stat, calc, number 4. And linear regression AX plus B, and R is 0.63. There you go, guys. To interpret its meaning, you say, there appears to be, oops. I'm not going to say strong here because the R is not very close to 1. There appear to be positive correlation.
So if it's close to 1, it will be a strong correlation.
Exactly. There appear to be a strong positive correlation between the years employed and the sales. Test for positive correlation between the age. Oops. Sorry. Between what? Years? I'll clean this up, guys, and send it to you, and sales. Okay, so this is a HO. I forgot to change this from the assignment, so that's what we need to do. Okay, so I'm going to go to linear regression t-test, guys. Very easy test if you just put the right sign in there. So I'm going to go to stat and then scroll up to linear regression t-test. My X list in L1, you don't have to put your list in L1 and L2. You can put them in L3 and L4. It's up to you, but just by default, I go back to L1 and L2. And before you hit calculate, make sure to select greater than 0, guys, and then hit calculate. Okay, I got T. That's interesting. T is 2.158. And I got the p-value I don't know why it's scribbling like that. So the p-value is 0.0339. Okay, what's alpha here? Let's make it 0.01. It didn't say, so I'm just gonna make it 0.01 because I want a different answer from what we've done so far. Do you guys agree with me that this is bigger than alpha? So what's the conclusion?
Fail to reject HO.
Fail to reject HO. I will clean this up and send you a nice and clean version of the solution. Fail to reject HO, that means there is not enough evidence to conclude that correlation is significant between the years employed and the number of, and the amount of sales. This is the first question, guys, where we end up saying that we don't think that there is a strong correlation. And you can see R was weak. It wasn't very close to 1. We say there appears to be positive correlation, but when we tested, the population correlation, it turned up that there is not enough evidence to conclude that correlation is significant. Find the equation of the regression line. Well, you already did, guys. When you did stat calc number 4, you have the equation of the line. So actually, it shouldn't be a new question to you. So y equals, put the hat. I got A to be 3.529 x plus B is 37.916. Oops. Predict the sales in thousands of dollars if the years employed was 12. Can you guys do this? How do I do this one? You got the equation. Any ideas?
Would you plug it in?
Well, not for 12. We're not going to be able to do it for 12. And can you tell me why?
Because it already gives you.
Because it's not in the range of values for between 2 and 11.
Oh.
If I change this one.
No, there's a 15 there, Mr. Bazzi.
What is it?
There's a 15 there.
Oh, there's a 15. Oh, I'm sorry. I didn't see that. So then you're correct. I need to check my vision, guys. That was very fine print. Yeah, we can, because 12 is within the range of 2 and 15. So I withdraw what I said. So it will be 3.529 times 12 plus 37.196. And what is the answer? It doesn't seem like we're going to be able to do the Socrative activity. I was planning on this one, so I'm going to leave it, but I need to take attendance before you leave, guys. 3.529 times 12 plus 37.196. You get 79.54 thousand. So it's 79,544. And let me see if there are some other questions. I don't think so. And if I take you back now to, I'm gonna stop sharing and share screen again. Okay, look guys, this is your assignment. Is there a D? Oh, an E. Predict the sales in thousands if the years employed was 20 years. Do you guys agree with me that for 20 years you couldn't do it?
Yes.
Because it's outside the range. Find the coefficient of determination R squared. R squared turned out to be, let me tell you what R squared is. It was 40%. So you say 40% of the variation in the amount of sales can be explained by the variation in the number of years on the job. So only 40% of the relationship can be explained. That's why it's not a strong relationship. So this is the one. Let me show you now your assignment. Okay. You have the age and the systolic blood pressure. Find the correlation coefficient R and interpret its meaning. Same question as before. Test for positive correlation, guys. Exactly what we did in the practice. Find the equation of the regression line. Exactly what we did. Predict the systolic blood pressure for an adult who's 63. Let's see if we can do the 63. Yes, we can do the 63 in here. You can see it. It's 65 is the highest number, so it's good. Predict the systolic blood pressure of an adult who's 72. Do you see the range that 72 is inside the range here, guys? Yes or no?
No.
No. So then you would not be able to predict it. And find the coefficient of determination R squared and interpret its meaning. Whatever R squared is, let's say R squared turns out to be 75%. So you say 75% and the variation in the systolic blood pressure can be explained by the variation in age. I'll